Hello and welcome to 9.3, last video. So in this video, we were talking about the geometric mean. So usually when we think of mean, we think of the arithmetic mean, which is where you add two numbers together and you divide by the number of numbers that you added, right? We've been doing that since, I don't know, a long time, elementary school probably. But there's also something called the geometric mean, where you, instead of taking two numbers, adding them and dividing by 2, you take two numbers, you multiply them, and you take the square root. So it's kind of the same idea of the arithmetic mean, where you're finding the thing in between, but this time you're finding the thing in between such that when you multiply each number, it's going to be multiplying by the same thing instead of adding the same thing like it was with the arithmetic mean. So that's what the geometric mean does. So it helps you find the a term that's in between two terms for a geometric sequence, just like we used the arithmetic mean to find a term that in between two other terms in an arithmetic sequence. So let's look at what this is going to look like. So for example, if you're looking for the geometric mean of 36 and 9, that's going to be 36 times 9 square rooted. So if you put that in a calculator or did it in your head, you would get 18. I don't think I could do that in my head. Most of you, they don't know what 18 squared is. Anyway, so you would get 18. So that means that you could write this as a geometric series, 36, 18, 9. And if we think about it, we'll try to figure out what our common ratio would be, right? Our ratio would be 1/2. If I multiply 36 by 1/2 or divide by 2, right? It's the same thing. I would get 18. 18 times 1/2 is 9, right? So this is a geometric sequence with a common ratio of 1/2. But there's one problem here, because remember when we take the square root of something, we have this uncertainty that we add in. So there's actually a plus or minus in here. There's actually a plus or minus there. This could be positive or negative 18, and either of those would actually work in terms of a sequence. So we don't know which one it is. It could be positive, it could be negative, because if it were negative, then that just means that instead of our r being 1/2, r is going to be negative 1/2, right? If I multiply this by negative 1/2, I'm going to get negative 19. If I multiply negative 19 by negative 1/2, I'm going to get positive 9. So it could really be either one, and without more information, we can't figure that out. So with that in mind, let's look at this next example and use the geometric mean formula to find what goes in the gray box here. So the numbers on either side are 8 and 32. So I need the square root of 8 times 32. That's backwards. Oops. I don't know what happened there. Okay. So times 32. So if I put that in a calculator, I am going to get 16. I'm going to get 16. So, whoopsies. So what goes in this little box that I'm not going to be able to write small enough in is 16. It does not look like a 16, but it's 16. This is 16. Okay. But now we have to ask ourselves, is it positive 16 or negative 16? And if we only knew these three, we wouldn't know. It could be positive, could be negative. But we have one more piece of information in this case. We have this 4, and we know that this 4 is positive. Well, if this were negative, then every other number in the series would have to be negative as well. So if skipping this one, the next one would have to be negative, then you'd have a positive, and then a negative, and then a positive, and then a negative, and the same in the other direction. The 8 would be positive, but the next one this direction would be negative. But we know that this is a positive 4, so this has to be a positive 16. So sometimes if we have one more piece of information, we can figure out whether or not our missing piece is supposed to be positive or negative. That wouldn't necessarily always be the fact. For example, if instead of this, I had been given 2 blank 8 blank 32, then I could have figured out that this was 16, and I could have figured out that this was 4, but I would not have known if they were positive or negative because I don't know, because the positive or negative only affects every other term, so I still wouldn't know. So I have to have kind of 2 in a row sort of situation, preferably, in order to tell whether or not it's going to be positive or negative. Another way to think about it is if I only have like terms 1, 3, 5, the odd terms, or I only have the even terms, then I won't know anything about positive or negative. So with all of that sort of in mind, let's look at this problem. It says the 9th and 11th terms of a geometric sequence are 45 and 80. What are the possible values for the 10th term? So first of all, we only know 2 points. We only know the 2 points on either side of the one that we're looking for. So we won't know if it's positive or negative. So our answer is going to have to be positive or negative. We don't know. We don't have enough information. So we're looking for the 10th term, which is directly between 9 and 11, right? So I'm looking for the 10th term, which is just going to be the geometric mean of the 9th term and the 11th term. So that's the square root of 45 times 80. Putting that in a calculator, I would get 60, but as I mentioned earlier, that would need to be plus or minus 60. So it would be plus or minus 60 would be our 10th term. We don't know if it's plus or minus. It could be either. So if you're looking for a term in between 2 terms of a geometric sequence, you can use the geometric mean, and in fact, you want to use the geometric mean, but you won't know if it's positive or negative, so you just have to write a plus or minus in front to say that it could be either. Hope that helps, and that concludes 9.3. Let me know if you have any questions.